Okay, this is my assignment 5 networking video, take 2, because I wasn't recording the first time. Right, so calculator. Add, set, multiply, divide, very easy. Has the internal result and then all of the stuff. When you call it explicitly, it works just fine. For data driven, you have calc data. There's an enum for the calc type. So you save the type and the value in this guy. So you set the data, and then when you do work on the data, you just do the switch and then call the appropriate thing. So that works just fine too. And then with queuing, everything's fine. For the FSM, I was kind of gross about it and just did the enum. So you have the enum of the state and the private state variable or class member. Advanced just does this gross switch statement to figure out where to go. Set just outright sets the state. So once again, explicit calls work just fine. For data driven, I used a kind of command pattern. So basically, you set FSM data with a particular action. So the action is the base class, FSM action. It has execute method. There's the set action, which holds the enum that you need, because set requires an enum, and then advance requires a byte, so the advance action holds that byte. And then you set them when you create these actions, and then when you execute either action, you call the appropriate thing. So advance action calls advance, set action calls set with the stuff that they're holding inside them. So yeah, when you do the set, you create one of those based on the thing, and then when you call do work, you execute you execute the data's action. Right, it's not that complicated. I'm just having trouble explaining it. So that works fine with the data-driven stuff, and then when you add in the queue, nothing breaks, so that's all good. For the interwoven test, there's another layer of command pattern on top. So basically, there's base class message, FSM message derives from message, and then calc message derives from message. FSM has FSM data member, calc message has calc data member. So then your input queue is just a queue of generic messages. You can either add a calc message or a FSM message to the queue. Then when you process them, you loop through and call execute. And for FSM execute, it will do work on the FSM data, which will then go and do the other stuff I already talked about. And then the calc message will call do work with the calculator with the calc data. So the queue is just made up of messages. It doesn't know which kind of messages, and then when you call execute, you do the appropriate stuff. And only the FSM stuff holds the FSM stuff, and only the calc stuff holds the calc stuff. So I think I avoided all of the what not to do's with that. And here's the output just in case. So yeah, that is all I have for assignment 5.